per square seconds. So I'd like us to solve that question together. We are given a body of mass 4 kilograms is attached to the hook of a spring balance hanging from the roof of a lift. So we have a spring balance in a lift. What is the reading of the spring balance when the lift is A, ascending at an acceleration of 0.3 meters per square seconds? So in this case again, we are simply being asked what is the reading of the scale. Our scale here is the scale in the spring balance. One, when the lift is ascending, So when it is ascending, simply it is when the lift is moving upwards. To ascend is to move upwards. And therefore, when we want to get the reading, we simply come and apply the formula for the lift moving upwards. And therefore, the reading, therefore, will be equal to mass gravitational force plus the acceleration. The mass is 4 kilograms. So we have 4 kilograms. Then we have the gravitational force, which is 10 meters per second square. Then plus acceleration, and the acceleration we have been given as 0.3 meters per square seconds. And therefore, the reading will be 4 multiplied by 10.3. And that will give us the reading on the scale. So we are going to have 10.3 multiplied by 4, which is 41.2 newtons. 41.2 newtons. And that will now be the reading. That will be the reading of the spring balance. That will be the weight. That will be the force that will be recorded by the spring balance when the lift is ascending. Then when it is descending at this acceleration, we consider now the lift moving downwards. So we are going to have therefore mass gravitational force minus acceleration. Our mass again is 4 kilograms. Then our gravitational force is 10 meters per square seconds. Our acceleration we've been given as 0.2 meters per square seconds. So we end up getting 4 multiplied by, this will be 9.8. So we end up getting the weight in that spring balance is 4 multiplied by 9.8, which is 39.2. So we get 39.2 newtons. That is when it is moving downwards. You can see when it is moving upwards, you can see that the weight here is more than the weight of that body, because the weight here is 4 times 10, which is 40. There we have 41.2. So we have some, no wonder someone will experience some force or some pressure exerted on the foot or on the feet. That is when he or she is standing on a lift that is moving upwards. Then we have ascending at a constant velocity. We have seen that if it is moving, a body or a lift is moving at a constant velocity, when the lift is moving at a constant velocity, therefore the reading will simply be the weight of that body, and therefore the reading therefore will simply be mass times gravitational force. So we'll have 4 kilograms multiplied by the gravitational force, which is 10 meters per square seconds. We end up getting 40 newtons. That is when it is moving at a constant velocity. So that is what we have for the Newton's third law of motion. For every action, there is an equal and opposite reaction. Then we have also been able to derive formulas whereby when we have a lift at rest, when we have lift ascending, and when we have a lift that is descending. Then also we have seen that when the acceleration is equal to gravitational force, the body will experience weightlessness. And we are also saying that if the lift is moving at a constant velocity, the reading on the scale will simply be equal to the weight of that body. So these are the formulas that you are supposed to employ, especially in solutions of any question under the Newton's third law of motion.